this thing on? Are we live? No, but we are here with another video. Shocked Pikachu face. What? Another one? You mean she's not giving up? No, not yet. So this is going to be a brief one because we're just going to talk about kind of a big idea. And this big idea will connect lots of things that we're talking about. And this big idea is called homeostasis. And basically what that means is our body is trying to maintain the same balanced state inside of us at all times, no matter what. So I'm going to give you lots of examples of how that works. So let's just kind of get out what is it. You know, your girl had to have The Simpsons on here. Okay, so what is homeostasis? Like I said, it's a big idea. It's your body's way of maintaining balance inside of you. So your body, maybe as you know or don't know, will respond to stimuli. So like if you see something scary, you're going to your heart's going to start beating faster. Maybe you're going to sweat, you're going to run away, or you're going to freeze, depending on how scary it is. Oh no, I didn't do any of my work so far and I have zeros. You know, that might cause your heart rate to go up. That didn't happen to any of you guys though. So no need to worry, right? Right. Yeah. So, you could be outside and you just came from the nice indoors and you walk outside and it's the middle of summer. It's like 98 degrees outside. The sun is like beating down on you. You're going to start to sweat and your cheeks are going to turn red and you're going to want to go back inside. So why does your body react to different stimuli? Things you see, things you feel, things you hear, things you taste or smell. So our bodies have all these senses, including ones besides the five senses, that take in the world around us and help us experience them. Your body and brain also are trained to recognize what is threatening or what could be dangerous to you. So our bodies are designed to react to those things and keep us balanced and keep us alive pretty much almost at all costs. So let's take a look at this picture. So here's you, maybe. Look at that big part of the brain that says biology. Yeah, that's my brain has even a bigger section. Well, I might have a TV section like that. Yeah. Anyway, back to reality. Oh, there goes gravity. Oh, never mind. Okay. Never mind with that one. We're not. It's too much of a Friday to be rapping. I'm not Eminem either. I like to eat M&Ms. This is why I need an editor to cut out all the stupid stuff I say. All right, so here you are normally, and let's say you exercise or you go outside and it's really hot. Okay, so the stimulus is, I'm warm, and your body needs to maintain the same temperature inside you. We're endothermic or warm-blooded, trying to maintain the same temperature inside of us. So if it's very warm outside, well, our internal temperature is also going to go do, 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 and start increasing. Well, our body's response to that is to start maybe breathing heavier and maybe sweating, because the sweat will cool us and hopefully the temperature will go down and we'll go back to normal. Or like how I'm used to, you go outside and it's freezing for 6 months out of the year. This is why I moved. And you start shivering even though you have on a shirt and a sweater and a jacket and a coat and a hat and gloves and scarf and boots, because it's just that cold outside. So you start shivering and maybe your nose starts running. Well, you might decide to rub your arms, but you don't decide to start shivering. That's something that happens involuntarily. That's your body moving your muscles and tensing them up to try to generate heat to warm you back up so your internal temperature doesn't drop and you experience hypothermia. So this is a long, complicated way to say your body is going to take action to make sure you maintain that balance that's going on inside you right now, that you're going to be even. Here's something that I saw on a test one time. They were asking about homeostasis, and they were saying, what about what happens when a creature goes out in the cold and experiences repeated muscle contractions to stay warm? And the answer ended up being homeostasis. Repeated muscle contractions. I always ask people, what do you think that means? And they're like, I don't know, convulsing or something. I'm like, they meant shivering. They could have said shivering on the test, but they didn't. That's why I hate these standardized tests. Okay, that can be on record. I hate them, and I don't think that they show whether anyone knows anything or not. Just saying. So my pro tip is, if there's a question and one of the answer choices is homeostasis and they say anything about balance, homeostasis is the answer. Okay? Yes. Perfectly balanced as all things should be. What is this? Am I 17 again? Yeah, my mom wouldn't let me game for 9 hours. Well, she wouldn't let me. Sometimes, anyway. Perfectly balanced. Like homeostasis. I think this is a trend we need to, oh Lord, this is a trend we need to start. Science memes. Please start science memes. I need them. Send me your science memes. Send me your best science memes. We're gonna make this a trend. I think this has got to be like a monthly thing. Science memes. So, what are some examples of homeostasis? Shivering when you're cold, so like your muscles twitching, contracting. Nobody says it like that. Shivering, so you can build up some heat. Sweating, when it's hot out to kind of cool yourself. Being thirsty, if you don't have enough water in your body's going to send signals like you're thirsty. You need to drink something. Hydro homies. Being hungry, if you have used up a lot of your energy by exercising or just existing, you need to eat. Your body will send a signal like, hey, you need to put some more food. We need some more energy. So get on that. Doggone it. Your heart beating fast, maybe when you're frightened or after you're exercising, or breathing heavy when you're tired, so you can get more oxygen to your blood so you can make more energy. And we're going to learn a little bit later, not too much later, that our bodies use that oxygen to create energy in the form of ATP. So if you've used a lot of energy, your body will breathe more. You'll be like, whew, so you can get some more oxygen to your muscles so they can, oh, sorry, no. You're not ready to see that. Okay, so how does our body do all these things? Well, your body's made up of cells, and all those cells and organelles have specific jobs. And if they're able to carry out their jobs, they're going to maintain homeostasis. They're going to continue doing that function, like your heart muscles are going to continually contract to beat your heart. When your cells are doing those jobs, they're going to be provided with all those building blocks, energy, heat, water, whatever your body needs to continually do that. That's on a cellular level, just like your heart is made up of a bunch of heart cells. If the cells are doing its job, the heart can keep doing its job. And what's controlling all of it? Part of your brain. It's part of your brain is constantly working to keep your heart beating, to maintain balance in our body. It's not the frontal part of our brain. That's the part where you have your thinking and emotions and like imagination. So it's not like the developed part of our brain. It's like closer toward the brain stem, like it's actually like a part that lots of animals have. They are able to maintain this balance in their bodies. Your cells also make buffers to balance pH. You don't want your blood to get too acidic or too basic. You don't want your stomach to be too acidic or too basic. Because, for example, like your enzymes that we talked about won't work. Why did I add that in there? If you're in my class, which you are because you're watching this, there's one of the things describes like, well, make sure the students know about buffers, that they'll raise or lower the pH or maintain a balanced pH. So buffers help to balance pH. If you know someone who has a pool, they might add little chemicals to the pool so like the water doesn't turn green, or like you go in if they add too much and it's like burning your eyes, it hurts. Those are buffers to help maintain the right pH so that stuff doesn't grow in it, but also you don't get burnt when you go in. So those are what buffers are. I'll talk to you more about those in class, or if you have questions, you just ask in class. So that's all I need to tell you right now about homeostasis. The summary is it's any action your body has that's going to maintain the balanced state of your body, the kind of stable resting state. So normal heart rate, enough oxygen and sugar in your blood, 98.6 Fahrenheit temperature internally. You really should go with Celsius, but that's for another day. All right. Well, if you have questions, just ask. I'm here. Don't you notice I'm like always here? I just live here. Okay. So anyway, I hope that helps, and I'll see you guys soon. Bye. You know what? If you're still here, you know what you should do? Like this video, subscribe. Come on. Don't you want to see me be YouTube famous? Like Mr. Beast lives down here. You and I can be friends, but I need your help. All right, bye for real.